We often like to think of sudden breakthroughs and eureka moments as the drivers of progress, but these are really the exception.
They obtain greater fidelity and stability.
More often, there is a long drawn-out process of piecemeal advances, setbacks, and struggles that eventually add up to something greater. But even when something revolutionary seems like it's within our grasp, it still requires a leap of faith. So today on the Serial Port, we're exploring the surprisingly complicated and contentious history of wireless networking. We'll be looking at a device that no one saw coming and talking to the people that made it happen. The history of wireless communication goes back to the late 19th century. But even during these very early days, people were figuring out how to both minimize radio interference and avoid radio jamming. One of the techniques that emerged is known as spread spectrum. This was famously utilized by Hollywood actress and inventor Hedy Lamarr and composer George Antheil in their development of a patented secret communication system in 1941 during the height of World War II. Spread spectrum works, as the name suggests, by spreading the transmission of information, which would normally be in a relatively narrow band, over a wider range of frequencies. The receiver, if they know the modulation scheme, can then despread the transmission to extract the information. To an outside observer, the transmission may look just like noise, which has obvious advantages for secrecy. The technique also helps avoid radio jamming, because the transmission is spread across a wider bandwidth, which can make some radio jamming techniques ineffective. Spread spectrum was actually classified as military technology until 1981. And in 1985, the FCC issued a landmark ruling allowing the technique to be used without a license in the ISM, or Industrial, Scientific, and Medical frequency bands. These included the frequencies around 915 MHz, 2.4 GHz, and 5.8 GHz. And with the newly opened bands available for unlicensed activity and spread spectrum authorized for civilian use, it didn't take long for new applications to appear. In 1986, just a year after the FCC ruling, Bruce Tuch, an electrical engineer that specialized in analog RF design, responded to a job posting from a company called National Cash Register, or NCR. Founded in Dayton, Ohio in the late 19th century, NCR manufactured the first ever mechanical cash register invented by James Ritty. And in the 1950s, they got their start in computers and electronics, and even jointly developed the SCSI interface in 1982. However, Tuch was hired for his RF expertise at their Utrecht facility in the Netherlands.
First project I was doing there was, I came because of the carrot of wireless research, but the first thing was actually a very standardized wired-based internet. NCR had cash registers connected, so you could call it their sort of intranet, I guess. And it was done over wire, and I was there to help design some of the cost reduction chip board. It was like 1 megabit per second over twisted pair.
That's when NCR began a feasibility study to determine if something called direct sequence spread spectrum, which is a spread spectrum modulation technique, could be used in retail department stores. Their clients wanted to connect their terminals and cash registers to the back office computers without cables, so that they did not need to drill holes in their shiny marble floors after redesigning store layouts. So Tuch and his colleagues created a prototype wireless transceiver as a result of the study. It operated in the 900 MHz band and transmitted at 500 kilobits a second. But even higher data rates were possible. A colleague of Tuch's, Hans van Driest, found that using something called the Barker code was the key to higher data rates. Without delving into too much technical detail here, this was a method of encoding a single bit of data in a wireless transmission that allowed data rates to reach upwards of 2 megabits per second with excellent range and resistance to interference, exactly what they needed for their application at the time. And after this breakthrough, Tuch had a realization.
This is really a wireless local area network, right?
The prospect of creating a wireless LAN was enticing, but Tuch knew that whatever they built, it had to work with existing protocols.
That was, for me, interesting to look at, to make strategically. Whenever we do, we have to make sure that we build something that doesn't require TCP/IP to be changed. How does bridging work? And could we do something that's a wireless bridge and make it look like any other bridge? So once the people plug this in, eventually they just think, hey, I know how to do this on Ethernet, and I could do it on wireless Ethernet.
But to get this kind of interoperability, a standard would be needed.
So how do you do that? And try to do that in a proprietary way, we thought wasn't the way to go, because one of the things with wireless connectivity is you need to either own the whole system, right, to have things communicate, or make sure the ecosystem is there. So if you're building a radio and someone else is building a different radio, if they don't communicate with each other, then you get in these fiefdoms, right? And all of a sudden there's not interoperability. Then you have to be the biggest player to make sure that this becomes a big system. So I said, no, this will be better to have this as a standard.
That's when NCR's Vic Hayes got involved with the 802.4L working group of the IEEE Standards Organization, the same place where the Ethernet standards were formulated. 802.4L was formed to investigate whether the token bus standard could be extended to include wireless. But after determining that neither token bus nor the existing Ethernet standard would be a good fit, Hayes submitted a request to create a new one. And on September 10th of 1990, at a GM plant in Oshawa, Canada, the 802.11 working group was formed, with Vic Hayes as the elected chairman. The meetings that week included dozens of participants from NCR, Toshiba, Motorola, IBM, and many other companies wanting to be involved in the formation of the new wireless standard. And amazingly, the handwritten diagrams and notes are still available to see from this first meeting. The working group would use NCR's design, now coined WaveLAN, as a basis for the emerging standard. But their work was just getting started. In 1990, NCR released their first WaveLAN products at Networld Interop in Dallas, Texas. WaveLAN operated at 915 MHz over one wireless channel, with a maximum data rate of 2 megabits per second. And in 1991, NCR was acquired by AT&T, and they continued to develop the WaveLAN range throughout the 90s. With the technology now out in the wild, but still no official standard, the next few years produced a bevy of new wireless products. These include products like the DEC Roamabout Access Point, a design licensed from NCR. Then there was Aeronet's AR-LAN, with both 915 MHz and 2.4 GHz versions. Proxim developed their RangeLAN line starting in 1991, and Symbol Technologies had their own Spectrum 24 system as well. But there was a problem. Many of these systems were not interoperable with one another, despite all of these companies having a presence in the 802.11 working group. And the prices were astronomical. While there were some successful applications of these early wireless solutions, PC manufacturers were apprehensive and few showed any interest due to the sheer number of proprietary solutions in the market and the high price points. And in 1996, AT&T restructured and created Lucent, which the wireless LAN groups now fell under. And among these setbacks and changes, the first 802.11 standard was finally published on November 18th of 1997 with little to no fanfare, and with some saying it was too little, too late. And over the years, the 802.11 working group had grown tremendously in size and scope. There were competing standards like Home RF and HyperLAN, supported by different camps and manufacturers, which were vying to gain control in the marketplace and claim wireless superiority.
802.11 at that time was getting a little bit more popular. It was still not there, but we realized we had to break the 10 megabit barrier.
And it all came to a head in May of 1998. The working group met for their biannual interim meeting at a Holiday Inn in Utrecht, Netherlands. Part of the agenda was to vote on 802.11b, an extension of the original standard which would support an 11 megabits per second data rate. Proposals of how to achieve this higher speed were put forth by several companies represented in the working group. Lucent's proposal had been voted down, so two contenders were left. One from Harris Semiconductor and another from Microlore, a relative newcomer to the scene. The voting was split almost evenly, with Microlore edging out Harris by a single vote. This was thrown into chaos, though, as a product manager from 3Com stood up and contested the entire voting procedure, claiming that members had voted along, quote, party, or in this case, manufacturer lines. This was against the spirit of the IEEE rules, which state that votes must be for what the voter considers to be the best technical proposal, regardless of who put it forth. And according to the 3Com product manager, this was undoubtedly Harris's solution. After this, the meeting erupted in conflict and went, quote, down in flames, and the working group itself was nearly torn apart by these events. However, cooler heads prevailed as representatives from both Lucent and Harris sat down to reach a compromise solution.
And actually, the compromise technology turned out to be, I think, better than either one. So it's not necessarily the case usually that when you compromise, it comes out better.
The end result was something called complementary code keying, or CCK. This was a new modulation scheme that not only improved performance over Harris's original proposal, but decreased complexity in the original Lucent scheme. With the solution now in hand, what 802.11b really needed was the right company, one willing to be bold, to take a risk, and introduce wireless to a wired world.
There has been so much that's happened in terms of network computing, as an example, that Apple's completely missed out on.
Steve Jobs had been back at Apple as interim CEO since September of 1997. His mission was to bring the company back from the brink of bankruptcy, and part of that plan was resting on simplifying their product lineup. Jobs devised a new product roadmap consisting of 4 quadrants: a desktop and portable meant for consumers, and a desktop and portable for professionals. These would be the 4 new systems that would help reinvent Apple for the 21st century. Around this time, Les Vogel, a software engineer who had been working on the recently shuttered Apple Newton project, moved to the new group responsible for the consumer portable. This would eventually become the iBook, but internally it had a different moniker.
The original code name was 799, which was the target sell price. Now, we couldn't figure out how to build it for $7.99, let alone sell it for $7.99.
Vogel had known Steve Jobs and Steve Wozniak since he was a teenager, having met them through Alex Kamrat, who ran Call Computer in the early 70s. Vogel actually started working at Call Computer at the age of 15 and later attended meetings of the Homebrew Computer Club. Vogel eventually became an early customer of Wozniak's.
Woz upgraded my HP 35 to an HP 55. I believe I gave him money for that.
Vogel had originally been tasked to work on implementing the CPU on the iBook, which was now internally referred to as P1. However, Apple wanted something to differentiate the new system.
We wanted to have home networking. So we looked at every technology we could. We looked at infrared, we looked at power line, and we looked at wireless.
But these other technologies all had insurmountable shortcomings.
So it came to wireless. But I had been doing the research for wireless, and it kind of got to the point where if we were going to do it, someone had to be leading this project. And so I asked to lead it, and it meant I gave a CPU, which people told me was crazy. But I'm like, wireless is more important.
Vogel then recommended that Apple rehire Dick Allen, who he knew from Apple's Advanced Technology Group. Allen had a presence on the 802.11 working group, and Jobs asked him to find the best-in-class wireless solution for the iBook. Allen then brought on Art Astron to help with the hardware engineering and manufacturing. Allen knew that the 802.11b standard was close to being completed. He also knew Bruce Tuch and had the confidence in Lucent that their wireless radio development was the most advanced.
With Apple involved, what happened there is, Apple was talking to us that sometime before. I got a call from Dick Allen. He used to be in California. He had a startup, Photonics, and he was doing wireless infrared. And so then he called me up. He goes, Bruce, I like your models and stuff, and I know you're doing a chip. Are you doing the new standard chip for 11 megabit that's going to fit the standard? I go, yeah, we're going to do that, right? So I morphed our technology. We were doing our own chip that got changed, and we're now doing the standard chip. And he said, okay, are you almost done? Yes. Are you going to, sell that product to other people yet? Not yet. We're not ready. Good. So he says, because I got hired by Steve to look at wireless. And I says, I know you, Bruce, and I think your stuff is good. So let's see what happens. And then he hung up, and then all of a sudden ripple effect,
Art Astron then went to Utrecht to meet with the Lucent team.
I remember flying there first month to Holland and meeting with the whole team. And they were also very depressed, demoralized, because they already been at it for like 10 years. And they had a product line called Waveland, which was a PC board and an Axis point, which was basically a PC, like a rack-mounted PC with hard drives and 2 slots for PCMCIA cards. And he was offered to sell it to us for $1,500.
Not exactly an Apple price point.
And Steve just went, okay, we'll talk to you later.
Despite this high price point, a meeting was scheduled with Apple and Lucent on April 20th in 1998. Prior to the meeting, the Lucent group gathered together at the Peppermill Lounge in Cupertino, just across from Apple's headquarters, to formulate a plan for success. The CEO of Lucent, Rich McGinn, had shown little interest in wireless networking and was mainly concentrated on multi-billion-dollar deals with telcos at the time. But he was a quick student, and after a briefing, he was able to talk about wireless technology like a seasoned pro, and they headed across the street to Apple HQ. The difference between the two groups could not have been more stark, with the formal business attire of Lucent contrasted against the California-style Birkenstock-wearing Apple crew. There was one notable person missing, though: Steve Jobs. The room fell into an awkward silence, but thankfully, Jobs finally walked in, needing no introduction. Jobs immediately took over the meeting, laying out his vision for the iBook and why it was the right time for wireless. As Case Links, a manager at Lucent, pointed out, presenting to Jobs was easy, as he would often do the talking and explanation for you. And that's when Jobs dropped the bomb. Lucent would supply the wireless NIC to Apple for $50. The room fell silent. Jobs stood up and left. This was a monumental challenge for Lucent. They had to deliver not only the new 802.11b NIC, but the access point as well. And both of these had to be done by the spring of 1999. But luckily for Lucent, they had an ace up their sleeve in the form of Doug Karl.
Okay.
Karl was a pioneer of wireless to Ethernet bridges, first developing them at Ohio State University to help link buildings across campus using early NCR wireless NICs, exactly like the one we saw earlier. This later morphed into his own company called KarlNet, which provided wireless bridges, firewalls, and specialized in outdoor wireless technology.
So because of that work that we'd been doing with the NCR card, somehow we got the attention of the NCR corporation, which was in Holland, in the Netherlands, and got a call or something, email, I don't know, that a couple NCR guys were going to stop by OSU and see what we're doing.
After attempting their own in-house software development, NCR turned to Karl, who ended up developing the embedded software for many of their wireless products throughout the 90s. The secret to Karl's success was his embedded software, which was extremely efficient.
And the reason that it worked, which was a pro and a con for the software package at the time, was the Karl was written in a highly optimized assembler, 386 assembler. And the reason that was is because the project that it came out of had to do full wire speed, Ethernet to Ethernet, and without fail, and it fronted all of the labs and buildings that we had at the university, because we had a need for that of packet filtering a bridging, firewall thing at the border of each building. And so we had to handle a lot of traffic, and the only way I could get that to happen is by I had an oscilloscope on the motherboard watching the timing of every one of the instructions and how long it took from one packet to another to actually process that and where. I mean, it was fun, but it was very detailed.
And in 1998, NCR, then Lucent, asked him if he could help on a project for a consumer device. But little did he know at the time, it was for Apple.
So we negotiated a price for that, which they never told me who it was. They just said, well, we'll probably get our volume up. And I was like, great, if the volume goes up, that's great. So we got a little bit of a one-time development cost. And then they said, oh, okay, well, that's fine. We signed the contract. And they said, well, it's for Apple. It's a consumer item. They're shipping all around the world. There'll be hundreds of thousands of them. And I'm like, oh, crap.
With the cat out of the bag, Karl provided Lucent with a list of required components necessary to implement his software. The Lucent developed access point was powered by a single board computer with the AMD Elan SC400, a processor based on the 486. And Lucent used their newly developed 802.11b compliant PCMCIA wireless card as the radio. The access point could be connected to an existing wired LAN, but with broadband still out of reach for most households, an Apple-developed 56K dial-up modem was included as well. And then there was the product design itself. Astron worked with Johnny Ive, Apple's legendary design chief, to come up with the physical design of the access point, which was actually inspired by a mushroom-shaped lamp in Astron's office. And with all three companies rushing to meet the deadline, there were a number of challenges close to production. Tuch received a phone call from Alan complaining that the access point was not working.
What do you mean it's not working? Well, I turned it on and it doesn't work. And it turns out that the paint they used was metallic. So it didn't work because he had a Faraday cage with our antenna inside it. So I say, I go, hey, this is not going to work, Dick. And it was a secret. I couldn't see what the casing was, right? That was why he says, yeah, I know, but we can't. I said, you have to tell them. They go, we can't change it because, Steve, he accepted it. If you tell him something is a reality distortion field, he'll tell you to change the laws of nature. And so what they did, eventually they found their paint guys, and they found a paint that was plastic in the composition that had the same glossy look. So that was able to be done. So that just shows you the development scenarios going on there.
With that crisis averted, the airport was ready to debut. But Apple had gone one step further. They had so much faith in wireless that they built antennas into every single device from that point forward. They were betting big on wireless, and this could be either Apple and Steve Jobs' next world-changing innovation, or a monumental fumble. So on July 21st of 1999, the airport was ready to be unveiled at Macworld. Except there was a last-minute problem.
Just before doors for the announcement, we couldn't get anything to work. Steve was like, well, we'll just not announce it then. At the last minute, I noticed that the router, the lights on it were going crazy. I'm like, who's using it? And we finally found in the green room that Frank Casanova had been streaming QuickTime movies. Steve called Doors, and we figured out we're just going to go with it live and hope that it works. And we stopped Frank from streaming.
And it did work. With Jobs' signature flair, after debuting the new iBook to the crowd, he said,
Well, but there is one more thing. Let me just show this to you for a minute, okay? I'm going to go to CNN Interactive here and see what's on CNN. There's CNN, you can see. And maybe I'll go to Disney here. I can come on over here. Let me show them show these guys how it works. Come on over here. You want to sit behind me there? Yeah. So I can just go to Disney.com here. Oh, you notice something? Thank you. You notice No wires. No wires.
The airport card would sell for a near unbelievable $99 and the base station for $299, far lower than anyone in the industry thought possible. And it sold in huge numbers. Their first day saw 150,000 units sold, another 150K the second day, and again on the third day. The demand was so high that they had to shut down online orders on the fourth day after launch. The question of whether the public was ready for wireless had been answered, and it was a resounding affirmation of Apple's big bet. The airport kickstarted the next generation of wireless into overdrive, and the PC industry was scrambling to play catch-up. Michael Dell was reportedly furious that Apple had beaten Dell, and in fact the entire PC market to the punch. And shortly after the airport's release, 802.11b was finally approved on September 16, 1999. The 802.11 working group, now at nearly 100 members, celebrated this achievement in Santa Rosa, California, with Vic Hayes still at the helm as working group chairman. The history of wireless is complicated, with twists and turns, successes and failures, but here we are today, where 802.11 signals are nearly as ubiquitous as sunlight. From its meager beginnings at 2 megabits per second, and now supporting multi-gigabit data rates, 802.11 completely transformed how we use our devices and freed the local area network from the confines of the wire. But so much of its success is due to the airport and the company that took a bold risk in betting it all on wireless.
That whole saying, I'm going to come out first. A company like Apple was willing to take that risk of saying, I'm going to put it as, in every PC. It has to be this price, and we're going to create the market. But I would say that was a important inflection point where Apple, launched, and and then everyone else got on the bandwagon, right?
I think Apple was the right company because we worked hard to simplify it. Our goal was to solve home networking. We just wanted it to be easy.
So to celebrate this incredible device, we're setting up our very own Apple Airport to dial into the serial port ISP so that we can recreate the magic of discovering wireless for the first time.
All right, let's try to connect wireless graphite. Connect.
And we did it! We're online and connected to the internet with the airport. It's incredible that this really all started with wanting to wirelessly connect cash registers back in the 80s. And all of these devices that are in millions of households today can trace their roots back to the airport. And it's thanks to the dedication and passion of the pioneers of wireless and the audacity of people like Steve Jobs that were willing to take a leap of faith to change our world. Thanks for watching the Serial Port, and we'll see you next time.